Welcome to all. Today is question number 5. Locate centroid. Class. Very important for some reason. First of all, some doubt will come. Some person may ask, Sir, such a shape, you told that lamina, we discussed lamina here, etc. Correct. But in structural engineering, where you get such shape? No, usually you won't get it. Such a shape of cross section will not come. Then why are you wasting time? I am not wasting time. See, I am covering not only for structural engineering knowledge, but also I want to help people who are going for academic examinations or competitive examinations. So this type of question I saw in so many question paper earlier, but they don't give 1, 2, 3, 4. They usually give only this much. Sufficient, they will tell, okay, this much they will give. Or sometimes they will give you this way, okay, this way. 2 vertical, 1 horizontal, 2 horizontal, 1 vertical. This much they will give. But I decided to extend further, little more. And now, somebody will ask, what is the purpose? In this question, you will understand correctly how to get the missing dimensions, or when the data is given, using the given data, how to get all required dimensions. Okay. So therefore, this is very, very important. And by learning this question, you are not losing. Your knowledge will improve, not reduce. So now, see, something in the class I will tell. You have to divide into parts. We have 2 options. See, either this way, you write, now there is no space to write anything here. So some of the statement I am dictating. See, let us divide into rectangles. How? See, you have one option. See, divide like this. 1, 2, 3, 4. 4 rectangles. Or another option is dividing like this. Dividing like this. Any option will do. This is option 1. Option 1. This is option 2. Option 2. Whatever you do, remember I noted the answer there. It has to come. Your division or option will not affect the final answer. It is unique. See, centroid is there. Nobody can change it. Okay, leave it now. Now start. Okay, anything you can do. We will do option 1. Right now, option 1. You write statement here. Solution 1, you should write solution 1, or I told division as per option 1. You write there. Okay, then start. Divide, you are right. Let us divide the given lamina into 4 parts as shown in figure. 1, 2, 3, 4. Now, you require all the dimensions. See here. You require this thickness. You require this depth. Every part. Then you require for this rectangle, this thickness. Anywhere. Okay, let thickness here. Space is not there. This thickness required. And we want width from here to here. See, if I project, see, not this one, from here up to here. This is the width. See, this is the thickness and depth of 1. This is thickness and width of 2. Up to here, full. Up to here you require. This is the thickness you require. Where to write it now? Okay, here. I will write somewhere here. This is the thickness for 3. And also we require, this is the, here I can mark. This is the depth for that third part. Lastly, you require this width and this thickness. Okay, first you enter which are given for you. Before that, someone will tell, Sir, you are not given 2 dimensions. I cannot give the 2 dimensions, because if I give a random dimension, it becomes nonsense. Because only, see, when data is given regarding dimension, only required data should be given. Extra data given will not match, or there is a rule. If you can construct geometrically this one in a drawing sheet to scale, if you can draw this sketch in a drawing sheet, if you can go for graphical sketch, then analytically you can solve. It's a rule. But remember, like, see, graphical solution, more circle is there in stresses and strains. And earlier or long back, graphic statics was there, where funicular polygon all used to come. Nowadays it is removed. But more circle, there is that one you can also solve analytically. So anything which can be solved graphically can be solved analytically, but anything which can be solved analytically, they may not be able to solve, we may not be able to solve graphically. So analytically ultimate. So now see, how to start? Start from here. How to decide? These dimensions are okay. See, from here you start. Come left by 30, you got this point. Come down by 175, this point you got. Go right by 245, you got this point. Come down by 185, you got this point. Go right by 125, this point came. Go up by 20, you got this point. Come left by 110, this point came. Go up by 190, this point. Oh yes, we started here, we ended here. Now, through this point, draw a vertical line, horizontal line. This intersection will automatically come. That is, given data is exactly the required. Given data is exactly the required data. No nonsense data is given here. Okay, now, see now. This is 30. See, this is 30. I will put right mark. Right means given. You write there directly. And one more thing. This is 20. Oh, thank you, sir. 20. Anything else given? That's all, I think. That's all. Further, no, don't see there. Don't see there. Okay, now, you require this depth. See, correctly. This all you are right. Depth for 1. Vertical dimension for 1. Total is 175. Oh, we stopped here. So from here up to here, see, we stopped here. This distance we want. If you want that distance, you should know what is thickness. See, this thickness of second part here. If you get this thickness, you can get this dimension. So you tell it, hey, please wait. Please wait for some time. Come to this member, this part. See, this is 190. This is 20. So from here up to here, full top, here to here is 190 plus 20 is full. See, this full from here up to here, 190 plus 20 is 210. This is 185. From 210 subtract 185, you get this thickness. So this thickness is, how much I got? 25. I got it. 25. I am rounding off. How you got it? How you got it? 190 plus 20. How I got? 190 plus 20 is from here up to here. Up to here. See? Yes, no, from here up to here, full. From this level to this level. 190 plus 20. Subtract 185. Subtract 185. You will get 190 plus 20 is 210. 210 minus 185 is 25, correct. So we got 25. Now thickness of 2 is over 25. Now next, we want this thickness, this base required. Now one thing, once you get this one, you can get this one. Please wait. I can go to please wait now. See, this is 175. This thickness, just now you got 25. So this is how much? 150. Now please wait is over 150. That's how you got it. From 175, that is the overall depth here, fully given here. Subtract this 25. Subtract 25, that is thickness of 2. Second part, okay. This cleared, this cleared, this cleared. And this thickness, this width will get it later, 1 minute now. I think we can get the width now. No. Unless the thickness comes, you can't get the width. See, if you want this full width rectangle, this is 30. This is 245. To 245, this thickness you have to add. See, the rectangle is from here to here, from here up to here. So to 245, you have to add this thickness. Then only you will get it. So therefore, this width also, please wait. Please wait. Okay, come. Get this thickness first. Thickness of 3, right here. Correctly. This thickness. It is very easy because, see here, 125 is full base. This offset is 110. If this is 125, this is 110, this thickness will be 125 minus 110 is 15. Rounded, we calculated. How I got? 125 minus 110. Okay. Thickness came. Now, as soon as you get the thickness there, 15, you can get this thickness. How? This width. Rectangle is from here up to extreme here. that is 245 plus 15. It is how much? It is 260. 260. Rounded. How you got it? 245 plus which one? 245 plus this thickness is 15. 15 is thickness of 3. That is thickness of 3. That's how you got 260. Now, this width is, oh, that is given directly 125. Oh, this is 125 given in the question, full width. Now, we want this depth, that is here. This is 190. From here to here, from here. See, from here to here is 185. Anybody can tell. See, our division is here. See, from here up to extreme bottom is 185. This thickness is 20. So, only from here to here is 185 minus 20 is 165. How I got? From 185 minus 20. 20 is thickness of fourth part. You write all these. Those who want 3-4 times you practice. And make a note. You make a note. Even in the notes also I will tell how I got the dimensions. I have to write 10 pages there. No. For that you refer the class, go through the class and write your own words. How different dimensions came. Okay, now this is one. Option 1 we are doing. See. Now full dimension 30. 215. That is extra data. 1 minute now. This is not dimension of any member, any part. 30. I want to come up to here. Every gap to be filled up. See, this is 245. This is 30. So from here up to this point, see, up to here is 215. How you got? You write there 215. 245 minus 30. This thickness, just now we got 15. It is here 15. See, 15. This extra length here. 1 minute now. Next. For this rectangle, full base is 260. I already got here. See, 260. And for this rectangle, see, project here. For this rectangle, up to where? That rectangle. See, some mistake there. Oh, up to here. Because see, sometimes some small mistake means gone. See, for this rectangle, this is how much it is? Not 125. 125. That is 125. Now, then offset will come here. How to calculate that one? From 125, subtract 15, or see here, this is 125, subtract 15, you get this extra distance 110. Here remember, this 150, see, but not required. You make a note. This rectangle is 30 by 150. See here, area figure 1, 30 by 150. I wrote it. Area A in mm square, 4500. This rectangle area is base, see, full base, 260 up to where? 1 minute. It is 260. Oh, some mistakes here. It is 260 up to here. Oh, problem. Okay, no problem. 260 up to here. Then that other one, how much? 125 is, see, here. This is 125. Or I can write here only, that I can write, no, I want only one side. Okay, no problem. See, this rectangle is 260 up to here. Then this rectangle, oh, it is here. From here up to here, see, this rectangle, they are overlapping, no problem. This is 125. That since it is 125, this is 15, this is 110. That's what you can make. After all, high school or primary school level mathematics. Okay. So this area is 30 by 150. See here. This area, 260 by 25. I wrote here. This area, 15 is the thickness into this depth. 165. I wrote here. Fourth one, full from here up to here. See, 125 by thickness is 20. Written here, see, thickness 20. So you get the total area. So that I don't have to explain once again now. Now, everything is clear. Make a note, some statement you are right. This I will remove now because I I will remove that one. Some statement I will give now. This I will remove. Okay, all correct, nothing wrong. I will remove this one. I explained for you everything. 360. Okay, another 1 minute, forgotten. Okay, this also I will remove. Option 1 you are doing this way. Okay, this is 360. Okay, that was important. I want the full dimension. How much? 260 plus 110. See, from here to here is 260 plus 110. That's how I got 370. Then, or you can do one thing. 30 plus 215 plus 15 plus 110. Somebody will be laughing. 215 plus 230, 240, 215 plus 15 is 230, 330, 340 plus 30, 370. Okay. Full depth I want. You should calculate. 150 plus 25 plus 165 plus 20 will be 360. I am rounding off because calculated value. Okay, this is also over. Now write statement. Let us consider reference axis OX and OY as shown in figure. See here. O here, X this way, Y this way. Which one? Bottom left extreme corner. This I told those who are going through all the classes, they know by this time. See, this left extreme edge here, come here. Bottom, see, or see here. This point, bottom, X I will take right side, Y I will take upward. Okay, now correctly get one by one. A1, A2, A3, A4 I have agreed. So total area is A to be total area, A1 plus A2 plus A3 plus A4. I wrote the answer. Now correctly get X1, X2, etc. See, start now. Those who want right, let X bar be centroidal distance from OY axis to the right side. Let Y bar be centroidal distance of centroid from OX axis vertically up. X1, X2, X3, X4 are distances of centroid of each component respectively 1, 2, 3, 4 from the reference axis, and Y1, Y2, Y3, Y4, A1, A2, A3, A4. Story you write yourself only. Start. Now correctly, see, this is your OY. Extend it here. See, usually I write OY not there. I write up to here. This is your OY. Not so early. Dot, dot, dot. This is a space problem was there. Okay. This is your OX. Okay. Start. X from OY line. This way, right side. G1, G2, center. All center because rectangle. See here. X1, 30 by 2. Somebody on the road will agree. 30 by 2, 15. X2. This full base is what? 260. From here to here. Midpoint. 260 by 2. 130. Figure number 3, be careful. Figure number 3, don't see there. See, up to this centroid you require. 30 plus 215 will give distance up to here. See, from here up to here. Plus center of this one is 15 by 2. 252.5. High school mathematics. Figure number 4. You can do one thing. Okay, 1 minute. 30 plus 215 plus 15. 15. Or you can do one thing. Directly 260. I wrote that way. Okay, I wrote it. 30. Okay. 30 plus 215. 30 plus 215. What is wrong here, Nisha? 30 plus 215 plus 125 by 2. Yes, up to here. See, correct. 30 up to here plus 215 is up to here. See, up to here. Up to here. I should not explain that much. 30 plus 215 will give you up to here. Then this is 125. Midpoint of 125 is 125 by 2. Or you can do one thing. Instead of struggling that way, 370, you can make a note here. You can make a note here. See, for this one, you can make a note. Somewhere outside, you can make a note. See, I will put a dot here. The dot can be also written as 370 from here up to extreme end is 370. Subtract this half the length. 125 is the base minus 125 by 2. That also will do. So that will come 370 minus 125 by 2 is 307.5. Okay, over. Now, y distances. Start. Figure 1 is here. Up to here, centroid, from here. 20, don't see there. Figure 1. Oh, figure 1 is this one. Why are here? Actually, instead of struggling, you can do one thing. 20 plus 165 plus 25 plus 150 by 2. That also you can write. If you are eager, see, where is it? Y1 here. See, I'll put double dot here. The double dot you can write how? 20 plus 165 plus 25 plus 150 by 2. If you calculate, it will come 20 plus 165 plus 25 plus 150 divided by 2 will come 285.5. 285. No point. 285. Or think a little. Why you are struggling? From 360 subtract half this distance. This is half of this depth of rectangle. This is 150. From here to here is 75 or 150 by 2. From 360 subtract 150 by 2. You get easy answer. Okay. Figure number 2 here. See, from here, remember, 20 plus 165 you reached here plus 25 by 2. Crystal clear. Figure number 3. 20, see here, from here to here is 20, then plus this depth is 165. So 20 plus half of 165. You got 102.5. Figure 4. This is 20. From here to here is 20 by 2 equal to 10. Now do one thing. Right. Now it is your problem. Before that you are right. See, in the statement all you are right. We have expression for x bar, y bar, all you are right. If you are serious, you write here. X bar from y bar from x bar from OY line, y bar from OX axis, x bar is to right side, y bar is to up, equal to a1 x1 a2 x2 a3 x3 a4 x4 by total area, that is a1 plus a2 plus a3 plus a4, y bar equal to a1 y1 a2 y2 a3 by 3 a4 y4 by total area. You write all those statements. Now I won't waste time. Substituting x bar how to right side, from where? X bar from, see, reference line required, from OY line equal to, and also you get y bar and y bar which is upward from OX line, OX axis equal to, okay, equal to, see, now if someone will tell, oh, he wrote everything, he did not show the calculation, I will tell, leave my class. Do not open once again my channel, never open it. If you are subscribed already, unsubscribe, no problem. After so many questions, I told formula everything. X bar, A1 X1, A2 X2, A3 X3, A4 X4 by total area. Enjoy the calculation. It will come 144.362 millimeter. And y bar, A1, Y1, A2, Y2, space is not there. A3, Y3, A4, Y4. If it is academic class, I tell only once. Then, unless negative term comes, when the remote area is there, then I will tell in the class. Till I finish this subject, this chapter, if negatives are not coming, you should do it. 2 means A1, X1, A2, X2, A1, Y1, A2, Y2. If 5 are there, A1, X1, A2, X2, unless negatives are there, I won't talk. They will tell, okay sir, no problem. Okay, same, y bar you calculate, it will come 178 point, calculate, show the calculation, 178.087. Actually, it comes to 144.362248848. Real number came, calculator. I rounded to third decimal. How much? 144.362. Okay. Y bar I got 180, 178 from bottom, 178.0868545. I rounded to third decimal. That is how much? 178.08. Since 8 is there, 0.87. So I rounded it, millimeter, sufficient. Okay, now last step. Okay, last T, come here. Closing, come here. Therefore, centroid G will be as shown in the figure. Whatever given there, prepare a rough sketch, but somewhat to scale, important. Somewhat to scale. Write only boundary dimensions, only boundary. Okay, now there's a boundary, this boundary I wrote it, then rubbed it actually. Okay, I'll do it here now. X bar you got how much? Okay, yeah, Y bar you got how much? X bar you got 144.362 millimeter. Y bar you got 17, not you got, I got 0.87 millimeter. Okay, always write the full boundary. 360 is the full depth, and full boundary from here to here is outright complete dimension is there, 370. Write it here. Now, see here. From this line, X bar, how much? 144.362. See, from here to here is 245. And to center of this rectangle is, this is half of 245 is 100 and, it is not 245, sorry. This full rectangle is 260. Okay, 260. Half of 260 is 130. So it will cross this point because 144 came, its center is here, slightly that side. So I shifted that side. Axis, later remember, when you go to moment of inertia, this will be called YY axis. This will be called XX axis, not now, later in moment of inertia. So this is X bar 144.362, total 370. If somebody wants answer from that side, from 370, subtract this one, you get this distance. Here, Y bar, see how much you got? 178, see here. This is 185, from here to here, 185. 178, so slightly below. From the junction here, slight below, 178.087, total 360. From 360, subtract it. Those who want, get that answer. See, rounded means calculated, X bar, Y bar, entered. Solution 1 is over. Now I will do one thing. I will go for alternate solution. See, only for understanding purpose. Okay. Now do one thing right here, 360. That's gone. I will put one more sketch now. Now go for alternates right here. Solution 2. Solution 2, or you can call alternate solution. Alternate solution. What we will do is we will divide into 4 parts. 4 parts. But how? Not like last time. This time we will divide some other way. See here. I will put here 4 parts. How we will divide? See. This way is there. We will divide like this. This way we will divide. And one more thing we will do now. Last time when we divided, we took origin where? We took origin here, O. Now we will do one thing. We will take, change, at least alter. Here you will take origin. So that you are learning distance from that side also, and also division is different. But even then, that sketch will never change. It is permanently same answer. Okay, now need sketch out right. So now again I have to explain dimensions. Dimensions will change. So I will prepare the sketch and explain. Otherwise it will take a lot of time. We will start alternate solution. You write what all I dictate, you write. Alternate solution. Last time we divided, how? See, last time, see, we divided like this. That also you make a note. This way we divided last time. You make a note here. Then write. No, this time we are dividing this way. That is, vertically we will draw the lines here. See. This way we will divide. So, dimensions will change. Don't see there. That I am explaining. Start. First to write 30 already given, 20 already given, then 175. See, this full 175 already given. No struggling now. Now, you require this thickness. Already I told for you how much. This is 125. This is 110. So, from 125, subtract 110, you will get this thickness. That will come 15. See, question mark. It's a question mark. How I got question mark? 15 I got. How I got 15? From 125, subtract 110. And 120, subtract 110, correct. See, from 125, because we want this thickness, 125 minus 110, we got 15. That also clear. Then, this base you require. Now, this is 125. This thickness just now we got 15. So, how much it will come? It will come 110. How I got 110? See, our division is like this here. See, this way division. So, this full is 125, given data. From 125, subtract 15. What is 15? Thickness of the second part. Thickness of third part. Thickness of 3. That's how you got 110. Then, this 15 over. This full depth required. I already entered there full depth. See, no place here. I entered full depth here 210. How to get 210? See here. This is, first next, we want this thickness. That already I told you last time how to get it now. See, this is 190, this is 20. So this total from here up to top edge here is 190 plus 20 is 210. From 210, subtract 185. So we will get that thickness. Where is it now? Here, this thickness. This thickness. It is 25 will come. How 25 came? See, this full up to here is 190 plus 20. 190 plus 20. But full here 190 plus 20. That's all. Oh, directly you get it. 190 plus 20, 210. See, I already explained 210 for you. The full depth is, see, our depth is from here to here you require. See, from here to here is 185. That, I think, no, you go other side. Okay, first you get what? You're getting this thickness first. This thickness. See, this thickness is 190 plus 20. 20. 190 plus 20. Then from that one, subtract 185. 185. That's how you got this thickness 25. So this thickness over 25. That also clear. See, question mark. This is also clear. 15 clear. 175 clear. 110 is clear. Yes, very crystal clear. Why? From 125, subtract this thickness. Just now you got over. Now only missing is this rectangle. 30 by 175. This rectangle. 110 by 20. This rectangle. See, we want total depth. Total depth is depth from here to here. See, full depth 190 plus 20. Where I will write now? Space not there. Okay, I should write somewhere. Projection, there is no place. Okay, I'll write here now. See, this rectangle. I'll do one thing. See, I'll hatch later. Dot, 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 hash, and dot, dot, dot. Hash, dot, dot, dot. See, this rectangle. I think it's within camera. From here I want. This distance will be, see here, 190 plus 20. That is 210. Question mark. Now cleared. How? 190 plus 20. See, this full depth is 210. Here there is no place to write. I projected that side and wrote 210. Now everything missing. Now this width you require. That width is, see, This is 245. From our rectangle is here. This is 245. Subtract 30. So this is 215. How I got question mark? From 245, subtract 30. Okay. Now, every dimension is clear. Draw one more neat sketch. See here. 30 by 150, first rectangle. Second rectangle, full base is 215 width and depth is, where is it? Thickness is 25. Cleared. Next rectangle, full depth is 210, thickness is, where I wrote 15 here, see 15. That also clear. Last one, only this width is 110. Thickness is 20. I wrote here. Now, these are all over. See, this for further understanding, this cut distances from here to here is 150. This is 25. You already know it. See, once it is 25, from 175 subtract 25, you will get 150. 165 is what? See, 165 is what? It is extra distance. Okay, 165 is from here up to this junction. You may require it. 165. Whereas total is 185. How you got 165 plus another 20, 185. Whereas total depth is rectangle. You can do one thing. 185 here plus another 15. 25. Oh, this thickness is 25. 210. Or I already explained 210. First of all, these all you have to practice. First of all, someone will tell, sir, this is engineering class. You don't have to tell all these things. We are expert. Okay, be expert. I am not expert. Okay, I am weak in mathematics. Think that way. Okay, now, make a note now. All this over. I'll remove this one now. Space problem is there. Make all this note. All dimensions we got. Now, very little work is there. See. Now, write statement. Let us consider reference axis OX and OY, where right side topmost corner. See, right side topmost corner here. This will take O. Therefore, your X will be now this way is your X. See, from there, write it neatly. Space is not there. This is your X and Y will be the 210 is obstructing. 1 minute. 210 is up to where? The 210 is I write the 210. Where I wrote 210? I have some space problem here. 1 minute now. This is 210. Remember. This is 210. I want some space here. 210. Okay, now. See? This is your Y. This is your X. This is your Y. So, now write. Now, statement. Divide into 4 parts. X bar to left side from OY is A1, X1, A2, X2, A3, X3, A4, X4, right? Same way. Y bar from OX line, how? Downside equal to A1, X1, A1, Y1, A2, Y2, A3, Y3, A4, Y4 by total area. Prepare that one. Start. Areas. I will tell you something interesting now. See, I am also human being. I will tell an example for you now. Okay, area. 30 by 1, see, full rectangle. 30 by 175. This is 215 by 25. 15 by 210. Last one. 110 by 20. Here, 20. Areas are over. Correct little X. Now X is this way. Okay. X1, CG is here, centroid. 110 plus 15 plus 215 plus 30 by 2. No, you are wasting your time. Directly 370 minus half of 30. That's all. Or you can write dot here. See, somewhere you make a note. Or if you want to slowly come from that side, you write a note somewhere outside. For which one? For x1, you can make a note. I can also do this way. 110 plus 15 plus 215 plus 30 by 2 over x2, this centroid. 110, that's all. Don't come to 15. Because when you come by 110, you reach here. 110 plus, plus 15 required. 110 plus 15, you reach here. Then plus half of 215, you get the answer. Or you can do one thing. 370 minus 30 minus 215 by 2. That also will do. x3, very simple. How? See, from here. 110 up to here plus this thickness is 15, 15 by 2. Okay, got it. x4 is the easiest in the world. Why? Rectangle here. 110 is there. Its center is 110 by 2. Okay, over. Same way, y distances from there. y1 is very, very easy. Oh, now centroid, actually what happens is, see here, when I mark centroid, slightly down I have to mark. G1, this is okay. This is slightly below. Okay, slightly below. This is slightly that side. Okay, no problem. y1, this one. Total depth is 175. See, 175 by 2. y1. y2. 150 is from here to here. 150 plus midpoint. 25 by 2. Where is it? Here. y3. 150, see, 150 up to here. See here. 150, useful for you. 150 plus half of 210. y4. 150 plus 15 or 175 plus 165 plus 165 plus half of 20. Or you can do one thing directly. 360 minus half of 20. That is the best one. Over. Now correctly practice. Now substitute. Write correctly. Substituting. I don't know where the pen cap is here. Substituting your x bar to left side and y bar to down side equal to, I will calculate now. See. $225.638. Actually, it came 225.6377152 is x bar. Y bar from top edge, downside, is 181.913 millimeter. Actually, it came 181.9131455. Okay, these are the answer you got. Now, do one thing. Therefore, come here. Centroid will be, see now, very important. Oh, there is a problem of space here. I don't know whether I can manage it. Okay, I'll try. You write here. Space problem. In the extreme corner. I think camera have problem now. 1 minute. I check it. Any problem in camera? Yes, there is a problem in camera. So I will slightly tilt the camera. Or making entry. Slightly I will tilt the camera. Okay. Now I can manage somehow. Oh, no. Here, space is there this side. Oh, I forgot. Space is there this side. Oh, I already marked it. Why should I mark it on the screen? Okay. Okay, no problem. Slight tilting I will do. Very slight tilting. Okay, question number you may not be able to see now. That is not a problem. Who bothers about question number at this stage? Okay, everything is okay. Okay, now, see here. I unnecessarily rubbed it, right? Therefore, right here, come here. Centroid for the given lamina is as shown below. Centroid G. Centroid G is as shown below. See, now your reference axis is where, don't see this y all. Don't see these things. This is all will come later. Don't see that. You see only here. See. This is your O. This way is your X. This way is your Y. Okay, I'll write here only Y. Once again, I'll check the camera now. Maybe I've gone out of camera, means I will check it once again. Because I do not want anything to be hidden by you. No, it is clear. Yes, fully visible. That Y line has slightly become inclined. If that is, some people will be there to comment it. See, there are people who will comment. See, little zigzag line. Okay, what is there? Okay. See, such people, you cannot do anything. For trying to find fault, nowhere. Okay, Y. Now, from this OY line, X bar, we got 225.638. So, left side come same point, see, 225.638. This is your X bar. See? Now, this is your X bar. Then, what you do? From the total of 370, subtract, you get this distance. Or, now, see, this from the top edge, come down. This is your Y bar. Y bar. Then, from the total 360, subtract it, you get other distance. Then, centroid here. Later, you can call this as XX axis and YY axis if you want. This is centroid location for the question. Okay, now, one interesting point. What happened is, I wrote everything earlier. Why? To save the time. Whatever I tried, I am not getting answer. I tried 2 times, 3 times, 4 times. Very slowly, I checked all distances very, very carefully. Still, X bar was coming, not 144. It was from that side. It was not coming 225. It came 221. When I am fighting for such a big accuracy, gold, you weigh in milligrams. You are getting difference in kgs. What is that one? See, or see, in gold, if you are trying for a milligram weightage for a cost. If you get difference in grams, it is nonsense. I was not knowing what to do. Where mistake, where? Then what I did was, I took my calculator. I did not see the table. I never saw anything. I only calculated from here. See, I don't require table first of all. I can do calculation. I calculated, I got how much? 225.638. Then Y bar I did not go. Then I know something is wrong. Suddenly realized. See, I changed X and Y. Area will remain same. But component areas will change. See, the component area will change. Total area will come same. So, I thought it is already accounted. I forgot to change that component. See, earlier it was 150 by 30. Now it is 30 by 175. Same way, everywhere, dimensions are changing. So, because of the small error in areas here, it was not giving answer. So, therefore, see, human nature. Actually, when I did the calculation without looking here, I stood this way. See, I did not see anything. 30 by 175. 30 by 175 into bracket 370 minus 30 by 2. Okay, then that way. I did not see anything here. I got same answer. Then when I used the table, I am not getting the answer. Then slowly I checked it. Suddenly I realized, oh, area. See, area remains same. Even though area remains same, component area will change. So you should accordingly or change. Unless you change the component areas. See, total area I never bothered. It is correct. But component area will change. Then, actually one more thing I will tell you. Now it is nearing around 3:30 a.m. Actually today I had some commitments. I thought today's class not possible. Then I decided, no, I do not want to waste time. Let me upload this important class today. So, little feeling sleepy also. It is not a mistake. But I got upset. I will tell one more example. Just information for you. There is a method called Macaulay's method and conjugate beam method or moment area method. A beam problem for some person, I don't want to tell who, he got different answer by Macaulay's method and conjugate beam method. Macaulay's, he might have told, sir, I am getting 360 by EI meter deflection. Conjugate beam method, he told, sir, I am not getting 360. I don't remember how much. He told he'll get 390 by EI, he told. Something like that. I told, impossible. Of course, he told, no, sir. I tried 4 times. I told you, try 4 lakh times. I am responsible. If the 2 methods give different answer, that is the end of my teaching. Moment area method, conjugate beam method, strain energy method, or unit load method. Any method, double integration method, or so many methods are there for finding deflection, or later, statically indeterminate structure, SD method, MD method, then Kani's method, conjugate beam method, not conjugate, sorry, column energy method, strain energy method, constant deformation method, matrix method, finite element method. Whatever you do, I told, if one answer is 360, it is 360 only. It cannot be even 360.1. I will tell in my class, if one answer is 360, maybe 359.99, 360.01, that is because of approximation. Okay, but this is impossible. But he told, no, I tried 4 times, 5 times. I told, keep on trying every day 10 times. Then, finally, no, sir, I took correctly, sir, area. I said, oh, tell me, what you have done? He told, sir, this reaction in this test, okay, then minus 2/3 of base into height. Oh, 2/3 of base into height. Who told you? Sir, formula. No, that formula of 2/3 of base into height is valid only for parabola, for simple support beam in UDL, if you consider the BMD from support up to center. If you come, it is an intermediate point. Up to intermediate point, you cannot do it. Cantilever, you can do it. Reason is there. You have to go by integration. Then I solved integration answer. Finally, suddenly got so happy. Sir, same answer, sir. Yes, I told you. What I tell, once I make a commitment, it will be fulfilled. Maybe, see, but these things happen. Human error. See, I am a person who will forget very easily, but principle I will not forget. Therefore, see, I thought this already accounted. I went there, then but forgot. Component areas, some of that area will come here. See, finally it is same thing. But one thing is, internal distribution will change. So accordingly, that's why error came. But you are not knowing because why? I had not started recording. I was a little upset. But I was not worried. I was not at all worried. I decided, let it be morning, 6 o'clock. Still, I will finish and go, leave it. Then looked here, suddenly realized the mistake. Mistake. Forgot to change that part by part area. Okay, don't do it. Be careful. Anyway, you won't do it because when you solve, you are not doing alternate solution. But if you do alternate solution, if you divide in some other way, component area will change. This will change, I changed it. Okay, now this question, in the title I am writing, the extra title I will write, question number 5, some extra information I will give there. So those who are serious, thoroughly study this question, understand and improve your knowledge. Okay, thank you. We will meet next time. Class, I already told goodbye to you. When I saw here, see, I did not remember, I forgot to remove this OXOY. There are people who will comment, see, this is gone. That was the origin OXOY for the previous solution. I explained everything here, but I forgot to remove it here. So those people who go through the class, they will understand. Oh, sir forgot it because you saw it last time. Oh, everything written, sir got it. Okay, now this is for those who will comment. Someone will comment. He took one origin there, one origin here. Does not know concept. See, does not know concept. He takes one's origin there and also he takes here. I will tell, go open your eyes and see what I told. Such people, I should be harsh only. But you have not done any mistake in your life so far. You come to me, in front of me, see how many, I will see that you make everywhere mistakes only. If anybody challenges that way. So just I remembered, better remove it. So extra portion I decided to add. Okay, thank you.